Hello, everybody. Can you hear me? Okay. Let's wait half a minute for everyone to join. There are still a few people left, probably. By the way, drop in the chat where you are joining us from. That would be interesting to know.
So should we start? I think everybody. No.
Yeah. I think we can start. Okay. So let's start with a reality check. Every software eventually becomes legacy. Not because it's bad. Frameworks go out of support. Vendors stop releasing patches, and your competition adopts newer technology that allows them to move faster. If you delay modernization, your team spends more time maintaining the old code than delivering the new value. You'll see longer deployment cycles, higher risk of outages, and growing costs. And eventually, you'll struggle to integrate with new technologies like AI, automation, or cloud services. I'm sure many people in the chat here see themselves already. The good news is there are proven strategies to deal with legacy systems, and taking care of modernization in time. Will create an opportunity to save costs in the long run, also be more receptive to the market trends, and realize your business strategy for product development in a more predictable manner. And this is what we specialize in. In practice, we see three main approaches: refactoring, reengineering, and rebuilding. Each has its own purpose, risks, and benefits. Today, we'll walk you through them, share real-life examples, and give you a framework to decide which fits your business best. So we will give positive and negative examples from our practice, by the way, not only the positive ones, since we had all of them, and projects which turned out to be a challenge probably taught us better than those which were only success. And most of our projects are under NDA, so we will not be sharing the names.
So, but before we dive in, let's quickly introduce ourselves. I'm Andrew Lichuk, co-founder and one of the managing partners of Corsac Technologies. I have been working in IT since 2004, if I remember correctly. Wow, it's quite a long time, actually. And built a company with over 100 employees. My role is helping companies align modernization projects with business goals and ensuring architecture decision deliver real ROI.
And I'm Igor Omelianchuk. I'm CEO at Corsac Technologies. I'm in this business since 2012. Over the years, I've helped dozens of clients across industries transition from fragile, high-maintenance system to scalable, secure, and modern platforms. And I personally managed over 30 modernization and development projects. So let's define the terms with examples one by one to make them more clear. And we start with refactoring. So what's refactoring? Refactoring means improving the internal structure of your code without changing what it does. Think of it like reorganizing your office. Same people, same tasks, but better filing, cleaner desks, and smoother workflows. When does refactoring fit? Refactoring works when your business rules are stable. Your product already works, but the code is messy or hard to maintain. If you've got tests in place or can add them, refactoring reduces technical debt and speeds up the development. Obviously, it has its risks and limits. Refactoring doesn't fix broken architecture. If the overall design is outdated You can polish the code all day, but it won't solve the scaling or integration issues. And if you don't have automated tests, you risk introducing new bugs. The positive cases of refactoring in our practice were, for example, shortening development cycles by removing spaghetti code, a very common problem, preparing for a bigger modernization step later. Modernization does not always go in one step. You actually may have quite a few of them to get to the desired outcome. And improving developer onboarding on productivity, since not properly documented code and bad code in general increases the time of onboarding of the new developers, which means basically you're wasting money on them figuring out things which could have been given them essentially on the plate much earlier.
So now let's talk about decision anti-patterns for refactoring. The biggest trap here is refactoring without test action. Teams clean up code without verifying behavior and silently break the system. Another trap is trying to refactor everything actually. So when you just delete the whole code base and redo it from the scratch, when it's really needed, when what just really needed is a deeper reengineering effort. So refactor is valuable, but it must be done carefully with test and with a clear scope. Otherwise, you risk spending time without solving the real problems. Let's start with a negative use case from our practice that we have. Here's one example. We worked with a client who had a project in healthcare industry with an old code base written by several different teams. The problem was that development speed really slowed down, and the number of bugs kept growing just up to the sky. The code had no test coverage at all. So the team decided to refactor the code base without test because the deadlines were extremely tight, as it's a very common problem when the timeline is set strict and we can't really fit the needed work to be done with refactoring. As a result, the goal was eventually achieved, but it took much longer than expected because they had to fix newly introducing bugs and recover lost functionality. What should have been done here? First, write a characterization test, and only after that begin refactoring. Now let's switch to a positive use case of refactoring. Here's another example of the project originally built on .NET Framework. The problem was that legacy dependencies limited further development as modern libraries and tools were no longer compatible with .NET Framework. So the team initiated the structured refactoring process, replacing outdated libraries with modern equivalents, modularizing core classes, and improving code structure to reduce framework-specific coupling. As a result, through continuous refactoring, the code base evolved to a state where migrating to a .NET Core was a natural step. The system was gradually modernized without the code freeze, while the team maintained delivery of the new features.
Okay, thank you, Andrew. Now let's get a quick poll before we go further. Think about your system, your current state. Which of these issues do you face most often? So, is it long deployment cycle? Is it struggling to release features on time? Difficulty integrating with new technologies like AI or cloud services? Or are you spending too much on maintenance? Please take a moment to pick one of the items which resonate with you. That will help you connect the strategies we discuss with your own case. Okay, so please take a moment to do the poll.
Maybe you have more than one. So just indicate it, please.
In most cases, that's more than one for sure. Okay, I think we're done with the poll. Thank you everybody for that. Now let's go back and speak about re-engineering. So what's re-engineering? Re-engineering goes deeper than refactoring. Re-engineering means analyzing and transforming an existing system into a new and improved form. It often involves redesigning architecture, migrating platforms, or modularizing monoliths. When does it fit? Re-engineering is right when architecture itself is a bottleneck, when scaling, security, or performance can't improve with simple code cleanup. This is when your developers tell you they cannot implement a certain feature because the system cannot handle it, or it's just built differently and there's just literally no other reason for that. It's also fit when you need to migrate to the cloud or integrate new business models. Obviously, it has its own risks and limits. It requires more investment and careful planning than refactoring, much more careful planning. If done wrong, it can turn into an endless project. Especially you are, for example, hiring additional developers for that, and your existing team ends up spending all its time managing the new team. So nothing new can effectively be done for the project itself, but everyone is extremely busy and the costs literally double. But done right, reengineering allows you to evolve incrementally while keeping business continuity. What are the better use cases of reengineering? First of all, that's breaking monolith into modular services, which usually speeds up the development, makes maintenance a little easier, makes feature release a little faster. Next one would be moving from on-prem to cloud. That sounds like an old trend, but actually lots of software businesses still use on-prem technologies. And also that would be meeting compliance, security, or performance requirements, which, by the way, may change all the time. We know all the case when GDPR hit software businesses in 2018, if I'm not mistaken, and enormous amount of businesses had to do re-engineering of their services because they simply did not meet the compliance requirements of the EU, and that was a very, very big deal.
So what about anti-patterns here? The classic mistake is the lift and shift with zero architecture change. Companies actually they love legacy. They move legacy systems straight into the cloud, thinking that that's it. They modernize it, but all they've done is moving their problems to a new hosting bill. The system is still fragile, hard to scale, and expensive to maintain. So nothing really changed. True re-engineering means evolving the system, redesigning critical components, modularizing when needed, and making it cloud-ready, not just cloud-hosted. This time, let's start with a positive use case. As an example, we take a project designed as a monolith. It was in a social service domain. The problem was that initially a monolith was a great choice, but over the years, as the code base and the team grew, making changes and maintaining the system became really a big problem. New formal requirement for scalability, availability, minimal downtime, and performance also emerged. So the team decided that having a phased delivered approach to gradually move the system to a suitable architecture. Tactical transition the system into a modular monolith, making future transition to a distributed architecture simpler. As a strategical decision was to move toward the service-based architecture. And as a result, the stage approach delivered tangible benefits. development and support became smoother, downtime was reduced, and the time to market for new features accelerated, enabling the business to respond to change more efficiently. As for negative use case, again, a monolith project with extensive functionality in healthcare domain. The same problem, development speed decreased, maintenance cost increased, and there was a desire to scale up the team. The task that we have, the client required to implement a microservices architecture which required more people usually. As a result, the team size did not actually increase since the client changed its mind and decided to stay with existing amount of people, but they inherited extra overhead cost from maintaining the new architecture. So the development process became even more complicated, which resulted in missed deadlines and more cost and time for future development. What should have been done? Understand why the client wanted microservices and influence the decision. Microservices was a very fancy word some time ago, and many businesses, they wanted to move to such an architecture without understanding the implication and not evaluating the benefits with cost of its implementation. Microservices are usually more expensive to maintain and require substantial organizational changes in the development process. And as a second point, what should have been done is they should have considered alternative architectures like modular monolith, service-based, etc. And evaluated the underlying problem better without jumping to the solution which they could not handle at that
time. Okay, thank you, Andrew. Now, basically, this is where we can help. So if you are not sure which direction to take when modernizing your software, or how to better approach it and how to properly assess the existing state of your software, please contact us and book a consultation to get a modernization readiness review. That would be a structure assessment of your system, like a first step. We'll look at where you are bleeding costs, what blocks your growth, and what risks you carry by staying on legacy tech. The result would be a roadmap, what to refactor, what to re-engineer, and where a rebuild may be necessary. If you are serious about unlocking faster releases, lowering maintenance costs, and enabling new business opportunities, so we'd be happy to walk you through the process. You can book a consultation with us. The link will be shared at the end of the webinar, or you can just go to our website and use a contact form. Let's get to the third point. That is rebuilding. Rebuilding basically means throwing away the old system and starting from scratch. It's the most common option, usually suggested by software development teams, since they usually do not like to deal with the existing code. And we've been through that many times. When does it fit? Rebuilding is the right choice only when the existing team is truly, existing design, not the team, is truly unsalvageable. The platform is at the end of life cycle, essentially, or when the business wants to fundamentally redesign the product. So there is nothing to do with the old one already. Rebuilding is the most expensive and riskiest of options, actually. Projects often take years, budgets often explode, and hidden business logic from the old system gets lost. Those are very common problems with rebuilding. Value to the business is delayed until the new system reaches feature parity, and usually that actually takes years. What are the better cases of use of rebuilding? For example, when no modernization path is viable. The system can be so old, or it uses absolutely outdated technologies which are not supported, and there is nothing to do there really. Another case would be when you need a brand new product architecture. When you understand that the current architecture and current setup of the product does not meet your business goals and you actually need to remake it. Another case would be when the business is ready for a long-term reset. So again, your business goal for the future do not align with the existing product and existing product setup and architecture and functionality, and you need to full rebuild.
And here's the anti-pattern. Rewrite fever. Developers get frustrated and want to start fresh. They love it, just to rewrite everything from the scratch. But most rewriters fail because they underestimate the complexity in the old system. Also, the existing team may not be able to rebuild the old system since it has been working with a legacy system for many years and simply does not have real life experience with newer technologies and architecture that they need to move to. In that cases, specialized company can help build a new system, deliver it to the existing team, and train them to maintain it. Sometimes, instead of full rebuild, we recommend a hybrid approach. Incrementally rebuild pieces using patterns like straggler fig, while the old system continues running. Straggler fig tactics is when you gradually replace the old code with a new code, step by step, module by module. That way you get the benefits of a new stack faster without betting the business on a risky full tech revamp. So again, as for use cases, so positive use case. A project using old ASP.NET web page technology. The problem was it was no longer possible to meet new requirements for usability and performance. The framework was very outdated. So the task was to satisfy the new quality attribute requirements. As a decision, rebuild the web part as a single page application Angular with ASP.NET Web API. Actually, ASP.NET Core did not exist yet. So core logic was moved into a separate library, and the SPA Web API system was developed in parallel. Once ready, traffic was switched over from the old system. As a result, quality attributes requirements were met. The old system ran in parallel as a fallback in the case of critical issues and was later just retired. There was no disruption of service. So let's move to negative use case. So a project in the sport domain that had been in production for a long time, I think over 7 years, with many features and a lot of legacy code built over time. So the task was to build version 2.0 using a microservices architecture as it was requested by the client. As a decision, we decided to implement a separate project. One team supported the old version, while another built a new one. The problem appeared since the team had to develop features for both the old and the new system. So double work, which increased the time, budget, and complexity of syncing the functionality in the old and the new version. As a result, the goal was achieved, but it took much longer than planned. And many issues arose from differences in functionality between the old and the new versions, eventually resolved, and more resources were spent than had to be if a more viable project was selected. So in this case, what should have been done? Perform an incremental migration of the existing system using patterns like straggler fig or parallel run. nobody would need to develop the same feature twice, and lots of operational efforts and budget could be saved with that.
Okay, thank you, Andrew. We are pretty much done with the main part, I believe. And we have some questions. So now let's get to the Q&A. I will go through and pick the questions which I consider the most interesting, personally. Okay. By the way, I will not read any names, only the question itself. So don't worry about that. Okay. So, question number one. How do you actually measure if refactoring or reengineering saved money for the client? That's a very common question, I would say. What we do, we track financial metrics tied to development hours, infrastructure costs, and basically maintenance reductions. We see how much time we spent to build it. We see what were the costs before, what are the costs now, for example, for cloud services. It helps us to compare what would have been spent on rebuilding versus what was saved by improving the existing system. So we can be rebuilding, we can be reengineering, we can be refactoring. Maybe refactoring doesn't really fit here. But anyway, we'll have a very clear comparison of what was before in terms of cost and what is now. And the numbers make it clear whether it pays off or not. Okay. Now let's get to the next one. Which type of software usually requires the most long-term support? I will not speak about technologies. I believe that's not what the question is about. I will more speak about the scale. And the answer would be enterprise level software. It often integrates with dozens of internal and external systems, and each integration has its own update cycle, which makes maintenance extremely, extremely difficult. That complexity makes support, it makes support critical for the business. One broken dependency can disrupt the entire department and the work of sometimes hundreds or even thousands of people, depending on the enterprise you are talking about. The bureaucracy of the enterprise organizations, by the way, also can make it more difficult to implement the fixes, which aggravates the problem substantially. So the most difficult in terms of long-term support would be enterprise level software, which, by the way, means that if you are an enterprise and if you are considering modernization, that should be on your priority lists, and you should be looking at it all the time. Okay, next question. Okay, what's the hardest part for you personally when dealing with outdated systems?
Igor, can I answer this question, please?
Yeah.
Really nice question. So from my experience, it's APIs. So you see, when integrations stop working, the operations suffer immediately. I've had cases where a single broken API blocked financial reports for days. That's why businesses, they feel real pain where their systems start to age. We had cases when it happened literally a day before important presentation, and we had to work overnight to fix it. So APIs it is.
Okay, thank you, Andrew. And the next one. Do you think the legacy software market will shrink over time as companies adopt new tech? On the contrary, it will grow. Every product built today will eventually become legacy. Like whatever tech you use, it will eventually become legacy. Demand for updates, patches, reengineering will only rise. For example, recent Boston Consulting Group research also points out in that direction. Legacy is not going away ever. So we can certainly say it's a good business. Okay, and I think the last question for now. If I want to understand whether my system needs refactoring or rebuilding, how much would a consultation with you cost? Well, the first introductory meeting would be free. We have a call, we get to know each other, we go through your use case, and then we'll give you a clearer picture of options. Essentially, no strings attached. Even if we don't work afterwards, you'll live with a roadmap of options to help you make informed decisions. So if you'd like to, please book a call and we can see what you have in your system and what are the options which are available. And I think we're done with the questions for now. And generally, I believe that we can wrap up. Yeah, so before we wrap up, let's come back to the big picture. Legacy systems are unavoidable. Every product becomes legacy eventually. You will need to do modernization over time to stay competitive and be able to keep growing your business in a planned manner. The main practical steps, as we discussed, usually are refactoring, reengineering, or rebuilding. The key is knowing which path is right for you. Selecting the wrong approach can result in a loss of money, loss of time and business opportunities, as well as lots of organizational efforts. By the way, on average, modernization project done in-house takes from 1 to 2 years. That's what we've seen in our practice, again, many times. And you can calculate yourself how much it can cost you if you are going the wrong path for over a year, and then you need to scrap the results afterwards, and you end up in the same place where you started a year ago. So this is something to consider. And that's exactly why our modernization readiness review exists. We deliver a clear business-focused assessment and roadmap. So if you want to stop firefighting and start accelerating, please book a consultation with us, Corsac Technologies. You can find the link below and visit our website for that. And I think we're good. So thank you for joining us today. We'll be hosting more webinars on modernization strategies, including deeper dives into cloud migration, AI readiness, and cost optimization for DevOps. And we'd love to see you again. Have a great day.
Thank you. Have a great day.